Hello, my name is Santiago Martinez, and today we're going to be going over problem 3 of exam 3. I do have a little cheat sheet here of what rules we can see to use throughout this problem, especially the problem that we'll be looking at today, which we're going to be looking at condensing and expanding. So we have 4 rules usually. Let's run through those real quick. We have the property rule, which is if we have log base of m times n, we can turn that to log base m plus log base n. It's important to note that you can work backwards as well. We have the power rule, which is log base m to the p is going to be equal to p log base m. We have the quotient rule, which is log base of m over n will turn into log base m minus log base of n. Pretty simple as well. And then we have change of base. Log base m will equal log, the natural log, or excuse me, log base 10, which is just usually log, the common log, and log base 10 of b. Or we can also just rewrite it as log base m of ln of m, ln of b. Whatever you choose to use, you can rewrite it in a simple form, either one of those. And I'll make sure to reiterate which ones we use throughout this process of these problems. So if we go up to our problem, this is going to be a 2-part problem. We have expand and a condense, and let's start with our expand. So this is part A, and it's actually asking us to expand log base 3 of 27 root x over y z squared equals what? So remember, let's just define this real quick. Expand, simple terms, make big. We want to make this as big as possible, right? With using our rules. For whatever reason, if we need to do this in an equation to solve or do something in some regards like that, we need to make it as big as possible. So let's start off with what we have, right? So right off the bat, I'm seeing a division problem. I know for expanding, we're trying to get this all the way out, so we can use one of our rules. So the rule that we're going to specifically look for is the quotient rule. So let's write that out right here. I will be going back because I don't know how to spell quotient. I'm doing math, not spelling test. So a quotient rule. And then we're going to write it right here as well. That way it really burns into our head, right? So we have log base m over n will equal log base m subtracted by log base n. Beautiful. So let's rewrite this now. So we'll start off with these arrows to notate. So we should have log base 3. M comes first. So we'll have log base 3 of 27 root x subtracted by log base 3 of y z squared. All right, what's the second thing that we can notice? So right off the bat, I see 2 forms of multiplication, y times z and 27 times root x. That's just a thought process in my head. You could see something different. Let's analyze what we're actually looking at. So again, I'm seeing a lot of this property. I don't know why I didn't write the rule of this property, but it's just log base m times n. We'll split it up into addition with m coming first. So we can do that with both of our problems. So we can do, or parts of our equation, log base 3 of 27 times log base 3 of x, and this is plus, and we'll have a minus of log base 3 of y plus log base 3 of z. And this will be squared. So let's relook at this and analyze what other properties we can use, right? So right off the bat, you have to be able to identify different properties that we could use, whether that's algebraically or knowing our roots or cubes. So the first thing I see right away, I see a couple things, right? So let's train our brain to actually notice it. We know that if we have an exponent here, that is a property. Specifically, that is going to be the power rule. So we take our power and we can shove it up front, just to expand it a little more, make it a little prettier. Another thing that we know that we can do is that to write a power, right, and we'll elaborate more of these in writing, we can write this as 1 over x squared, or excuse me, 1 over x raised, right, as a power. So 1 over 2 should actually be what it is. And we'll write the rule for that, and I believe I have that on my cheat sheet as well. Up here, yep. So we can write it as a rule standing by this, right here. So I'm gonna write that again too when we actually do it. Then also the last thing I see is 27. We know that 27 is a cube number, and that happens to be 3 cubed. So let's break this down. So first thing, like I said, this is a cubed number, so we'll have log base 3 of 3 cubed. Beautiful. Let's walk this down just a little bit. Nice. Then we could do plus log base 3 of x to the 1/2. And then we're going to do minus, nothing here with the y, nothing fancy, log base 3 of y plus 2 log base 3 of z. Amazing. So right away, let's identify what rules we use. Right here, we can say the power rule. And you should write it out, that way you get familiar with what we're doing. So we have log base of m raised to p will give us p log base of m. Just a rule to remember. And then also, excuse me, my mouth's super dry. We can rewrite this, right? So if we have nth over x to the 4, or let's say to the m, make sure that's what the terminology I used up here in these rules so I don't confuse you. Yes, so n to the m, we should have, this is interchangeable, so we do arrows like this. We should have x to the m over n. And we get that because this is a squared root, right? So there'd be a 2 here, and there's an imaginary 1 here. Not imaginary, it is there. And then we then can write it as 1/2. But this can work for any radical. So now looking at our next part, we can see what we can work with. So this actually should be written like this. Excuse me, my apologies. 1/2. What else do we see? So right away, log base b is the same as our x, so we should be left with our exponent. So we should be left with 3 plus, using our power rule, 1/2 of log base 3 of x minus log base 3 of y I think I made a mistake somewhere along my work. Let's check it real quick. My apologies, I'm checking my work to see what I did wrong. There is a sign mess up here somewhere. Let's find it. So log base 3 of 27. We'll highlight all of our steps as well. That way it's a little easier to see with all the writing. So we use the quotient rule. From here to separate these two, which is going to be subtraction. And we see this here, so we used to separate this of using the quotient rule once again, or we should use, let me make sure I am doing this correct. Boom, 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 boom. Oop, too far down. Yep, it's plus here, and subtraction there. I think that's where I messed up. This can be distributed across these, so there should be a parentheses here. So this would actually be minus, so minus 2 log of 3 of z. Now looking at it, there's not anything else we can do. So that's fully expanded. So this will be our answer. Just be careful with your signs and know your properties, and you should be pretty a-okay with problems like this. So now we're going to be looking at part B. We'll change colors here. And this is a condensing problem. And what we will be condensing is 2 ln of x minus ln of y plus 1/2 ln of z. Quite a big guy, but 9 and 10 times you're going to see that it's a lot easier to work with if you think about it, right? So what can we see right off the bat? Well, right off the bat, I see two situations. We have this leading term, and we also have this leading term. So let's rewrite that. So we're going to have ln of x raised to the 2 minus ln y plus ln, this is at z. When you're working with 2's and z, make sure to add the cross. Make sure you can just tell between your work, however you want to do that. But I like to add a little line in between. And we should have ln of 1/2. Beautiful. Now what else do we notice here? So looking at this, we have an ln x squared, an minus a term, and we also have plus a term. So how would I go about solving this? I would probably condense this first part of ln y plus ln of z. So let's look at that. So we know that's times, so let's combine these guys. So we can use the same ones for natural log as well. Forgot to mention that. So we should have lx, that's going to be minus ln of y z. And I actually really do like this idea of condensing this further. So in fact, instead of doing this, my apologies, we will get to that in the next step. We should rewrite it as this: ln of x squared minus ln of y plus ln of root z. That way it makes it a little easier when rewriting into the next form. So we should do ln of x squared minus ln of y times root z. And then what do we see here? We see a negative, so we can write this as ln of y over z over 2, or x squared, excuse me. Absolutely beautiful. And I think the more correct way to, if we wanted to be super critical of what we're doing, we can actually rewrite it again using the same strategy, but just to really radiate maybe getting it right versus wrong, is we can write this term together first, right? So then we would end up with ln of x squared times y plus ln, oh, this is minus, excuse me. That is a mistake on my part. So we should have ln of x squared over ln of y. Oh, nope, all over the place, my apologies. Plus ln of z. We can also rewrite that as z still to make it easier. We see 2 pluses, so we can do ln of x squared over y times root z. And we could just do that over 1. And we could do ln of x squared times root z y. And that would be more correct. You can do multiple ways. The other way wasn't wrong either. It just depends on what you want to do and what properties you want to use. But this is a condensing problem and a expanding problem. Know your rules and you should be good. Thank you.